Hello, my name is Andrei. I'm a fan of devices, and we are talking here a mobile robot platform, which is an open source platform based on ADI technology, and our battery management will drive sensor. This platform moves together with the Arduino Portenta board and runs ROS2. So what we are showing here is an industrial mobile robot application for box management in a warehouse. So the robot is able to navigate on its own in an environment, detect where it is based on the sensing that's included in the robot, and move the boxes.
What kind of sensor are inside the robot?
The sensors that are inside the robot are a time-of-flight camera, an IMU, and information from the encoders that are mounting all the motors that's driving the wheels.
Perfect. And we can see also in the demo the positioning of the robot around.
So the robot has a built-in map, and it is able to position himself in the map based on the information that's receiving from the sensors.
Hi, I'm Jason Hanna. I'm with our Hedge AI team at Analog Devices, and today we're showcasing a partnership with Sony and work that we're doing with them on their intelligent vision sensors. So what you can see here, this is a simulation that we put together of visual inspection. So here you can see we have two Sony cameras. These are the IMX500. The cameras are capable of inference. So the camera module itself has a DSP and memory. And so the AI model is directly deployed onto these cameras.
Wow.
And what we're showcasing today is the ease at which customers can take solutions from Sony, combine them with solutions from Analog Devices to prototype their own products for visual inspection, for other types of AI and ML applications.
And just to count or not, also to expect?
Yes, so what the demonstration is doing here is we are looking at the candies. So the idea is, imagine this is a pharmaceutical application. So we're looking at the candies as they come across the conveyor belts. One camera that you see here is doing object detection. So these bounding boxes are saying these are Smarties that are coming across. So I should be able to take something like a jelly bean, put this on the table, and it'll say, okay, this is a jelly bean. It's an anomaly. This is a foreign contaminant. It should be part of this product. So the bounding boxes that you see here are actually beamed down to the processing unit you see here. And then we're passing it back up to the second Sony camera here. And we're scanning all of the Smarties and looking for anomalies. So we're looking for areas where there's a defect or there's an imperfection in the candy. And so what we're showing here is that we have two different AI models running on the edge, directly on the Sony processors. And then we're using ADI technology, GMSL, to serialize the data connection for resilience, for distance, for high speed, combining these two things together in a solution that's ideal for industrial applications. And the other thing that you can see here is we've incorporated ADI vibration sensors. So we've attached one of our 3-axis MEMS accelerometers to the motor control. And we are running an anomaly detection model here so that we can look for variations in the conveyor belt. So it might tap the table. You should be able to see events.
Yeah.
The anomaly model detects that there's some unusual vibration happening within the system.
My name is Colton McCallum. I am a software tools engineer at ADI and I work at CodeFusion Studio. Today we're presenting CodeFusion Studio and some of the amazing features that come with CodeFusion Studio. Specifically, we're presenting the system planner, the configuration and productivity tools, and multi-core debug. The system planner is our latest and greatest feature to come out of CodeFusion Studio. It provides a system overview for project creation and enables our developers to get started very fast and efficiently with projects on our SoCs. The configuration and productivity tools are already in CFS 1.0. Likewise is multi-core debug, and the configuration productivity tools are primarily used for pin configurations as well as utilizing a UI to visualize our executables such as our alpha explorer files. Then we have our multi-core debug. One of the benefits of our debug capability that we are able to debug bolting for SoCs with different architectures all through a single interface. And yeah, this is all readily available via the VS Code marketplace. And yep.
Hi, I'm Tom Sharkey. We're ADI here at Embedded World 25. And the demo I'm showcasing is a little bit of a mix based on motor control. We have both a condition-based monitoring sensor as well as some servo controllers and gate drivers from ADI Trinamic. So the first aspect of the demo that I'd like to show you is our condition monitoring sensor. This is Voyager 4. It's a wireless condition monitoring with a 3-axis MEMS accelerometer, some Bluetooth low energy connectivity, as well as an Edge AI system that can help you detect early on if there is a fault with your motor, so that you can bring someone in to maintain it before any faults error. The other aspect of the demo is the VLDC motor itself. So we have two different driver boards, both which control servo controllers. We have a pan drive stepper coder, which is driving the belt itself. You can imagine this for a type of bottling application where bottles are moving along a line and you need to place a cap on them. So that is what the plunger itself is doing. But really what we're trying to showcase is the highly integrated nature of our designs. So the motion cookie itself is this design on the right. Really bundles up everything you need for motor drives. So ADCs, analog front ends, and similarly with TMC9660, all of that same technology is included in a single chip. And we also do a hardware FOC control algorithm on board. So really, this demo speaks to all of the motor control that's available at Analog, including our condition-based monitoring. The whole idea is to make autonomous manufacturing more efficient.
And what you can see from the panel?
Yes, so our Voyager 4 is connected via Bluetooth back to a device. This could be a PC or iHab. Essentially what we're trying to showcase is that we're not sending back wireless raw vibration data. We're instead sending back some measure of the motor health itself. So for us, this is a reconstruction error from the specific neural network that we have running on board.
Ciao, buongiorno, sono di Domenico da Analog Device. Io principalmente di PFS o la Management System. Qui c'è praticamente una completa soluzione per il battery management. Partendo dal dispositivo che ci permette di monitorare la batteria completamente, quindi possiamo misurare con questo qui in particolare la corrente e la tensione di tutto il pacco batteria. E poi qui invece abbiamo i cell monitor che ci consentono di misurare la tensione ciascuna cella. Qui infatti abbiamo scopo esplicativo posizionato 12 celle che formano una batteria che sono monitorate da questo IC possiamo mostrare la tensione delle celle e anche di questi altri qui che sono invece dei simulatori di batteria, perché non avevamo spazio per impilare tutte le batterie qui. Quello che è il buono di questa soluzione è che possiamo monitorare le batterie e anche fare diagnostica. È importante quando si tratta di batterie di avere sicurezza. Questi IC ci consentono di fare tutti i controlli del stase. Le applicazioni sono varie, diciamo che queste parti nascono nell'automotive, però adesso possono essere applicate anche in industrial, in stoccaggio di energia, in elettromobilità, per esempio scooter, biciclette, e di qualsiasi dispositivo che ha delle batterie richiede il monitoraggio di essi e può utilizzare la mostra.
E a livello di dispositivi, e quindi nati proprio per questa applicazione, che cosa abbiamo? Cioè come chip proprio.
Come cicli? Sono due principalmente. Ci sono questi qui, e gli scompi. ADI GMSL per monitorare ciascuna cella. Poi per monitorare tutto il pacco abbiamo 2950. Di cui qui abbiamo le evaluation port che sono anche disponibili.
Quindi dicevi, questi sono chip che sono nati sull'automotive e che adesso stiamo un po' esportando.
Lasciamo come auto. Possiamo vedere la corrente che scorre nello shunt del battery monitor. Qui abbiamo posizionato un motore che si comporta da carico, quindi va a consumare corrente. Quello che mostriamo è che quando attiviamo il motore vediamo che la corrente ovviamente aumenta. Quindi questo ci consente di vedere che anche una corrente relativamente piccola, perché qui abbiamo solamente 48 volt, può essere apprezzata dal dispositivo. Quindi questo è di importanza perché gli consente di ottenere via delle correnti, delle brevi variazioni. Sia anche ovviamente quando parliamo di 200 volt più, anche di più stretti più elevati. Qui questa in realtà è la tensione che viene misurata sullo shaft e poi dipende dal valore dello shaft.
Riesce a calcolare la corrente.